Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to demonstrate how can we prove that the mean of a binomial random variable is given by this formula here, which is NP. N is the number of trials and P is the probability of success. So here is some little notes, sort of a guideline for you if you would like to try on your own first, and then maybe later on you can compare what you have got so far with what I'm going to show you next. Okay, so let me just walk through the little notes given here. So first of all, if you want to find what mu is, that is just finding the expected value of a random variable x. And since this is a discrete case, then you have to deal with the summation process where you are going to consider the product of x and its fx. Right, and you have to do some more steps in order to get to this part. And once you are done with that, you will simplify that by using a different representation. For example, you will let x minus 1 equals to y and n minus 1 equals to m. And of course, there are some more steps that you have to do in order to simplify the whole look. And at the end of the day, you'll be able to show that the mean of it is going to be equal to NP. So if you would like to try it first on your own, this is where you can pause the video and then come back later to see the solution that I'm about to show you. Okay. Right, let's get back to what we are supposed to do, which is to prove that mu is equal to NP, and we're going to start off with mu is equal to EX. And EX here is going to apply the summation process because X is a discrete random variable. So here is X. X is a discrete random variable, okay, and it is a binomial to be specific, and the values of x can take values such as 0, 1, 2 until n. Therefore, what we need to further define is this part right here where the values of x is from 0 until n. Now, what we're going to do next is we are going to write down what is fx. So here we go, we have x times with our fx. Well, what's fx? Fx is the probability distribution, and if it is a binomial random variable, the probability distribution is given by this formula. Okay, so that is the probability distribution, and we're just going to substitute the whole thing right here at this position. Okay, so we have nx px 1 minus p n minus x. Okay, now before we go on further, let me just focus a bit on this part here. What does it mean really? So the whole process, okay, let me just do a bigger circle. So the whole process here is actually substituting the values of x accordingly from 0 until n. For example, you can start with x equals to 0, multiply with f0 plus 1, x is 1 with the probability value for x equals to 1, 2 with f2, and it goes on until n and fn. And I hope you can see that at this point here, it doesn't give any useful value because the result here is going to be equal to 0. And therefore, we can start the whole thing beginning with x equals to 1 until n. Okay, so that's what we're going to do. Therefore, we can replace this 1 with the value of 1. So x will begin from 1 until n. Okay, so that's what we have. Okay, now the next point is that we are going to write down nx in terms of mathematical representation, which we have seen involves factorial. So we have x from 1 until n. This is x, n factorial, x factorial, n minus x factorial, px, 1 minus p, n minus x. Okay, now the next part is I'm going to focus on this one here, which can actually be represented as x times x minus 1 factorial. Okay, so x factorial, so x factorial can be written as x times x minus 1 factorial. Now, if you can't see what's going on here, let me just give you a simple example of real number. Let's say you have 2 factorial. 2 factorial is 2 times 1. If you have 3 factorial, 3 factorial is 3 times 2 times 1, and this is equal to 3 times 2 factorial, because you can clearly see that this part here is 2 times 1. 2 times 1 is this one, which is equal to 2 factorial. So you can just say that 3 factorial is equal to 3 times 2 factorial. Now, if you want to see more pattern, well, we can have 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and that can be written as 4 times 3 factorial, which I hope you can see clearly, because here we've got 3 times 2 times 1. And what is that? That is this guy right here, and this is similar to 3 factorial. Therefore, if you have x factorial, so if you have x factorial is equal to x times one number that is reduced by it, x minus 1, times x minus 2, and you go on subtracting one more value, you know, and until you reach number 1 at the end. And the whole thing here is going to be equal to x minus 1 factorial. So x factorial is equal to x times x minus 1 factorial. So we follow the pattern which you have already seen in this 3 cases above. I hope that is clear for you guys. Okay, right, I'm just going to call this part here 1, so I'm just going to label that now as 1. So based on this information, the current information that are given to you guys, therefore 1 can be written as, therefore 1 becomes as follows. Okay, so we have ex is equal to ex is equal to this guy here, and I'm going to replace x factorial with this one, this representation. And similarly, actually, you can do the same thing for n factorial. N factorial also can be replaced in a similar manner. So you will have n times n minus 1 factorial. Okay, right. Here we've got x is equal to 1 until n. This is x. This is n times n minus 1 factorial over x times x minus 1 factorial. This is n minus x factorial. P, okay, hold on. At this part here, okay, we're going to do another different way of writing this part. Now for this part, we're going to replace that with something else, which is P, and the power is x minus 1 times p. Okay, we're going to replace this whole thing with p x minus 1 times p, and then again here you have 1 minus p and minus x. Yeah, so here we got 1 minus p and minus x. Now what is going on right here? Well, we are not changing the original stuff, because if you have px minus 1p, that is just, so this one here is just px minus 1 times p. This is the same thing as having px minus 1 plus 1, the law of exponent. Yeah, and therefore negative 1 plus 1 will be cancelled out, so you will get back p to the power of x as what you have originally seen right here. So we're just changing the look of it, but we don't change the original term actually. Okay, right, so that's what's going on. And what we can do next is, you should be able to recognize that p here and n here are constants that don't depend on x. So the whole thing here is a process. The whole thing here is a process that depend on x. But n and p are the constants that don't depend on it. So you can take it out and just, consider that outside of the whole process. So let's do that now. We're going to take out n and p. So here we have np, x from 1 until n. And you can also see that x here can be cancelled out with this at the bottom. Okay, so what we have next is, we're just going to simplify the whole look. It becomes n minus 1 factorial, x minus 1 factorial, n minus x factorial, p x minus 1, 1 minus p, and minus x. Now we're going to make it look even more simple by doing another representation where we're going to let m represents n minus 1. So making it even more simple by calling this whole thing with just one alphabet, m, let's say. And we're going to call this with just one alphabet. So we're going to call it as y. So y is x minus 1. Okay. Therefore, ex is going to be no more ex. So therefore, because we're not going to have x anymore in this process here, so I'm just going to call that as maybe this is 2. So therefore 2 becomes, okay, so therefore 2 becomes np, and here we're going to substitute that with m. So here we have m factorial, and right here at the bottom here we have y, so this is y factorial. Now what happens to n minus x? So n minus x, so n minus x, what is n? N here is equal, so based on this equation here, we can say that n is equal to m plus 1. So here we got m plus 1 minus x here is going to be equal to y plus 1. So we got y plus 1, and by doing this process you end up with m minus y. That's what we're going to write down. On this part here it becomes m minus y factorial times with p. So x minus 1 here is going to be equal to y, 1 minus p, n minus x, n minus x is m minus y. Okay, we're just changing the representation of it really. Now what is the value that we have to put here? Now we don't have x anymore, but we have y. So you can see that here x begins from 1. Therefore, if you substitute 1 into this part, then y will begin from 0. So 1 minus 1 is 0, so y here will begin at 0. And if x is equal to n, y becomes n minus 1. But what is n minus 1? N minus 1 is this one, m. So we can write down y begins from 0 and it will stop at m. Okay, so this one here becomes np, and if you want, you can write down in terms of my. So this whole thing is actually combination, choosing y out of m, and here we have p to the power of y, 1 minus p, m minus y. This one right here, the whole thing here, is actually a probability distribution. We have seen this given right here. It's a binomial distribution, and we know that if it is a probability distribution, if you sum up all the probability from 0 until n, the result is going to be equal to 1. That is the characteristic of probability distribution, which you have learned in chapter 3. The difference that we have is we are just using different alphabets. We only have m and y instead of n and x, but it doesn't matter because it has the similar look, just different alphabets. So here we've got x from 0 until n, and here we've got y from 0 until m, and if you sum up, this is the probability. So this is the probability of getting y0, and then you add up with probability of getting y equals to 1, and then you add up until the probability of getting y equals to m. So the process of that, the process of adding up all the values here, will result in 1. Okay, so what we have here is we can write down the result here equals to 1. Now why is it 1? Again, because this is a probability distribution and you add up all the values of it, it should be equal to 1. Okay, so we can finally say that this is just equal to np, and we have managed to show that expected value of this thing, ex here, is going to be equal to np. Okay, right, that's all for now. Thank you very much for watching, and I will show you next how can we prove that the variance of random variable x is going to be this one. Thank you very much for watching, and I'll see you in the next video.